Good morning and welcome to another Micrographics webinar. Today's topic is Fusion 360, what's new in the major April update. I'm your host for today, Carl van Rooyen. I'm an application engineer at Micrographics. I do training and support for Fusion 360, both from a modeling side and from a CAM manufacturing perspective. And I do support for Inventor and Vault as well, to name a few things, as part of my role as an application engineer with Micrographics. So as mentioned today, Fusion 360, what's new? We're going to be looking at the April update, a couple of key highlights within the what's new April update. So on today's agenda, we'll start off with an introduction, just a base overview of the improvements. We'll go through then more specifically the new sign-in experience that I'm sure most of you have experienced already with Fusion, and just a bit of an explanation there on that new sign-in experience. We'll have a look at performance improvements, a lot of metrics on that slide, so we'll just have a look there at what the performance improvements cover. A couple of slides on the design environment, what has been improved and added to the design environment. Then moving on to drawings, just one or two small improvements in the drawings environment that we'll have a look at. And then manufacture, a couple of toolpaths and a couple of options in the manufacture environment. Some to do with your standard out-the-box functionality and a couple of them to do with the machining extension. Then we'll close off with a summary and followed up by a Q&A session. So for our introduction, the Fusion 360 development team typically rolls out quarterly product updates. You will see that there was a November update, a January update, and now the April update. So we're looking at specifically the April major product update and the different areas in the update. These updates typically bring updates to most of the workspaces, whether they are small quality of life improvements or whether they are large updates, overhauls, or the implementation of new features. They typically cover a wide range in these updates. On the right hand side, we can see a contents list pulled from the 2023 April major updates blog that Autodesk put up. Big thank you to Autodesk, the Fusion team, for always putting up these greatly detailed blogs with links to the specifics for each of these updates. That's a great resource there. We've got the link in the description of the video for that. You'll see on the right hand side, though, as mentioned, there's the major product updates looking at usability, design, electronic simulation, generative design, drawings, manufacture, API and add-ins, and also customer reported bug fixes. We're only going to be covering 4 of these. That's usability, design, drawings, and manufacture. Sort of covers the biggest general use case for Fusion without going into any specialized workflows or areas like electronics or simulation. So moving straight on from the summary, from the intro, going into the new sign-in experience. So you may have already seen, or if you haven't been using Fusion much, you may still experience this. But when you launch Fusion 360, before the update, you used to get Autodesk's sign-in window that came up to sign into Fusion 360 if you were not already signed in. Now what happens is you are redirected to a web browser and you will then sign in on the web browser. You can see here on the animation on the right hand side, so welcome to Fusion. You click sign in, opens up your web browser, you sign in, and you'll have a button in the web browser to be able to click that to go back to your product. Now, one thing I have noted, I use Chrome. When you click go back to product, Chrome picks up that you're trying to launch an application or that that link is trying to launch an application. So you'll get a warning that says, this application is trying to open. Do you want to trust it? And then you typically have an option there to always trust this application. So I suggest ticking that, so when you click go back to product, you don't keep getting that prompt every time you have to sign in and go back to Fusion. Once you click go back to product, your browser stays open in the background, but Fusion will then open up and log in the foreground. Now, what is the reason for this? Basically, Autodesk has moved away from their own little sign-in dialog box because there was no way to support password managers for that. And so what they're saying is, logging in through a web browser allows you to take advantage of your password manager plugins that you may already have installed on your browser. And it's also a more secure way of signing in for larger companies that have sort of single sign-on credentials. It allows them to take advantage of that. So you'll be able to sign in through the browser and then return back to the software. So that's it for the new sign-in experience. There's a small change there that may have already caught you out or may catch people out in the future. Then we'll move on to performance improvements. A lot of metrics on this slide, but overall, if we look at an overview of this, we're seeing that they are specifically targeting opening and saving of large files with some of these improvements. We'll see they're saving design files with large local SQL caches up to 10 times faster. The term large is also very open-ended. You'll see mirror components also 8 times faster, opening with large designs up to almost 51% faster, so half the time taken. Window selecting improvements there. You'll see a wide range, 58 to 130% improvement. That's going to be dependent on geometry and the amount of components that are being window selected. Once again, moving components vastly improved there on the speed. Also invoking pattern commands after selecting many bodies, improvements there, and improvements on expanding document settings browser to change the thread type when converting into direct model. So a couple of areas of improvement, claiming quite large improvements, 50% and more in some cases, 8 times faster in other cases, which is quite a lot. And so you should notice going forwards that some assemblies that large assemblies that you may have that seem sluggish, you should have a little bit of improvement there. What I like is the save times and opening times being improved as well. I've got a lot of customers that tend to moan about that on larger assemblies. Then moving on to the design environment, we're looking at a new option in the sketching in the sketching environment. When you create a sketch, there is now the option to create a blend curve. This is not under the create panel, this is under the modify panel. And so you would be able to drop that panel down, select blend curve, and in your sketch panel you would have the ability to select if that blend curve is going to be tangent, so G1 tangent curvature, or you're going to have G2 curvature for the continuity between the bridge or the blend that you're adding in. So that image on the right hand side there, we'll see this in a demo that I'll do a little bit later on, but we've got two existing surfaces and we need to bridge the gap between. That blend curve can be added by selecting the edges of the surfaces and that blend connecting those two existing curves. Somewhat like a bridge curve in other software as well. Then looking at T-spline faces, the subdivide command. Previously, when you wanted to subdivide faces, you would select your face, activate the command, or activate the command and select the face, and that command would be kind of locked to that face. Now you're able to deselect and select faces when the command is active, sort of as many times as you want, so you can change your selection when the command is active, and a preview is now shown of the division on the face. So as you select the face to divide, that preview is shown on the face. So we can see on the right hand side there the two faces selected with the division, specified division of 3 length and width faces. Once again, we'll also see this in a demo that I will do a little bit later on that will cover these slides. Going on to the automated modeling. Prior to the update with automated modeling, when you hit OK to generate your alternatives, you would be locked to that document and you'd basically be sitting watching this generate or prepare those alternatives. With this update, you are now able to switch documents and continue working on a different document while your alternatives are being calculated. So we'll see that the automated modeling panel will remain open in that document, and that command is not cancelled when you move to another document or starting a new command in the other document. So you can continue working in parallel with the automated modeling and continue working on other designs as your alternatives are being calculated out. When you come back to your document that is having the alternatives calculated, you will see that that automated modeling panel opens back up automatically, so you can then check on your alternatives. Inserting into current designs, so it has some improvements here when bringing in an external design to add to your assembly. Typically, prior to update, when you brought in your design, the latest version of that design would have been brought in. And the issues that we see with this is that if somebody else is modifying that design and they make changes and they save, the version increases, and you would then get a warning letting you know that, hey, listen, your component here has been updated. You need to then load the latest version. And if you had multiple collaborators on the same project, this could become quite annoying. You'd get a lot of notifications saying, oh, all these components are out of date, you need to update them. So now the new behavior is that when you pull that external referenced file in, it will bring in the latest milestone if that milestone exists. So if there is a milestone for that design, it will pull in the milestone version and it will keep that in your design. If there are any newer versions that may be going through iterations and they're being changed, you don't get a notification about those updates. What you can do though, or as you bring this milestone in, you will get the warning that you see on the right hand side, more of an information dialog box where it says you're inserting a milestone version. So in this instance, for the part that I inserted, it says I'm inserting milestone version 1, although there are more recent versions of Fusion. So if we want to update to the latest version, once the part is inserted, you can right click on that component or on that design file and choose the get latest version option. But you will notice in the browser there that it shows the file Fusion F version 1 with the milestone flag, but there's no warning to tell you that it's outdated because you've loaded that milestone. And then you can choose to get latest, and that will download the latest or update that file as the latest version within the design. So this makes use of milestones. So what if you do not have that milestone? Then if there is no milestone for that design, it will basically just insert the latest version into your design. Moving on to the drawing environment. For drawings, we will see that we have now the ability to add automated centerline and center marks. So here on the right hand side, I've got a plate with various geometries applied to it. We've got your standard holes using the hole feature. So the far right hand side, the drawing view panel there, we've got automated centerline section, which is now new in that panel, and you can set the 4 different feature types to pick up. So as mentioned, holes, so hole features, will apply center marks to hole features. round extrudes, so any extruded faces that are circular, it will find those center marks. Round cuts as well, so whether you're adding for the extrude or cut or removing material, it will find those circular faces, as well as a fillet option. Now when you enable the fillet option, that will also add the minimum and maximum fillet radius fields. You can leave them blank to have all fillets center marked, or you can put in a range there. So we can see with the range between 10 and 30 millimeters, only the bottom right hand fillet on that plate is being center marked. This also works for center lines. So if we had a side view, which we'll show in the demo, we would get center lines through those cylindrical surfaces or holes as well. So the ability now to add in that automated center line and center marks. Okay, so we'll move into the demo. I'm going to go over to Fusion 360 and we're going to start off with the blend curve. So here we have a model of two complex surfaces, and what I want to do here is bridge the gap between the two with a couple of curves. We'll see with the blend curve option we can go into the sketch environment. So I'll start a 2D sketch. Doesn't really matter where that sketch is in the environment, as the blend curve will be added as a 3D sketch entity. We'll go to the modify drop down and we'll see the blend curve option now in the modify drop down. Activate blend curve, and selecting a free edge on the model, an edge on the model, it will project that edge into the sketch, and then the second edge will also be projected and that curve added between. And we can see here that the blend curve has options. So when you activate blend curve in the sketch panel, you'll have some feature options: tangent blend curve, so G1 continuity, or curvature blend curve with the G2 continuity option. So for this side, I'll do the tangent, and we get this nice smooth arc that goes across the part. I'll flip around to the other side. We'll do the curvature blend. And previously when I did this, I did note some weird behavior with this. So just be aware that you may get some things happening. If we look here, I get this nice loop that splits around, and may need to adjust that a little bit. One little trick that I have done with this, if I just undo that and start it again, the blend curve, I'll keep it on tangent, add it across that side. Let's see if this works, and we'll go in and delete those tangent constraints. So let's get that constraint. We'll delete that one that side, delete the other one, and then we can go back in and add the curvature. Let's see if this works. There we go. And so we can then go back in and add the curvature. So that there just helped change it from tangent to curvature, seeing that the curvature option didn't give us a good result on that component. So just a little bit of a thing that I noticed there was specifically with this example, with that blend curve, but we have that ability to modify it and change it after the fact if we need to, because it's using those constraints, the standard constraints from your constraints panel. So it's a nice quick one there for blend curve. We could continue on now. If we finish sketch, we'd be able to do something like, it's got a surface, we could do a loft from one side of the component across to the other. So just our sort of standard loft practice here, and we can then add rails and use those curves as rails for that loft. So a nice quick way to bridge a gap, create a surface across that gap. Let's just go ahead here and reverse the normal on this face and get that nice continuous surface. Okay, so that's your blend curve option. Let's have a look at the subdividing of a T-spline face. So here I've got a dome with some faces on the top that I'd like to subdivide. I'm going to the subdivide command, and we can see that we can now select the faces or deselect faces to subdivide, and we also get the preview of the subdivision. So I'm going to choose here, I want to specify how many, and we'll add in as per the screenshot in the PowerPoint. In the presentation, we're going to go 3 length, 3 width faces. Let's do all 4. We can see the preview of how that face is going to be divided. We can then also see where those dividing lines will intersect the adjacent T-spline faces. We'll hit OK, and that subdivides up those faces. That's it. You would then continue on with your rest of your modeling from there. Going on to the automated modeling. This one's quite nice because we'll start the automated process. We want to connect various faces on the model, and we would like to, in this case, avoid this rod through the center. And we're going to create a new body from this. And so we'll generate shapes. And while we're generating shapes and it's working out the alternatives, let's give it a second or two here. There we go. We start seeing the alternatives. We can come back, go to blend curve, and let's say I want to change some of the loft settings here. We can continue to work and update this model as we're waiting for our alternatives to generate. So let me go ahead here. Just wasting a little bit of time. Continuing with other work as those alternatives calculate out. So let me just finish this off very quickly. Do those 2. Finish sketch. That's updated nicely. And now I want to go back to automated modeling. Let's see if we've got any results yet. That panel comes up and we can see that it's still preparing alternatives. So if we had an alternative, we could select it, click OK, and then add that in. But we can see that we still have that progress moving along there. While this goes on, let me move on with the rest of the demo. Let's look at inserting that milestone component. So here we'll go, I've got a blank assembly or blank part. I'm going to grab in this Fusion logo. We'll see if I expand that out. We do have a milestone, so there's version 1 milestone and then version 2. So we click and drag that in to insert that into the design. And we get that warning message or that information message that we saw in the presentation that we're inserting a milestone. So I click OK. You do have the option to choose do not show again, and you won't get this warning. And I'm pushing my laptop a little bit here, trying to do the automated design and inserting some files. I think what I'll do is once this is inserted, I'll go back to the automated design and cancel that if needed. Yeah, so there's the file. Hit OK. It's coming upside down, so let's just flip that over. And under automated design, we can see that I've got some alternatives. So I'm just going to grab the first alternative here, hit OK, have it insert that alternative. There we go. And so that's done. We can continue on with modeling up and continue on with the rest of the demo. So we'll see inserting that Fusion F with the milestone brings in the milestone. We can always right click on the milestone, choose get latest version, and that will update from Fusion F v1 to Fusion F v2, and that milestone flag should drop off. There we go. So now we get that linked Fusion v2 file. There we go. Last one for this demo, we go to automated center lines. Under automated center lines, we've got, or this example here, I've got a couple of different things. Top left-hand corner, I've drilled a hole and patterned that feature. So the set of holes on the top left corner, those are featured holes, or featured hole that's being patterned. The pattern is a feature pattern. I'm going down and confirm this. So object type features, where with the bottom left, that pattern, it's a hole feature, bottom left corner, but the pattern is for faces. This is just to show the different behaviors when inserting the center marks on the drawing. Then also we've got some fillets on the corners, a really small one here, bottom left. Bottom right, we've got a medium-sized one, and then top right, a larger fillet, as well as a couple of bosses that have been added to this plate. So just an idea on what geometry and features we have, so we understand the insertion of the center marks. So here my drawing already has some center marks. I'm going to double click on the view and we'll see that the hole feature is enabled. Note on the bottom left, only the original feature has been shown in that pattern because we patterned the faces. And so what we can do here is we can go to the center marks and choose other options here for the center marks. So on the top right hand corner, those bosses, if I go round extrude, they will be picked up and center marks added to them. If we go round cuts, the pattern on the bottom left will get all of their center marks. And lastly, the fillet options, we will get our corner marks. If we add in minimum fillet radius, let's say 10 and a max of 30, we will then only get the bottom right hand corner in there. Maybe I'd push that maximum up to 60. We then get a center mark top right. Then center lines. In this view, we won't get any center lines, but what I am going to do here is just put in center lines for round extrudes. And we'll see now when we create the projected view, that will be inherited across, and we get the center lines in the projected view. So even if you don't have those center lines or center marks in the base view, you will get them in, you could potentially get them in your projected view because those center line options are inherited across the projected view. So that brings us to the end of this demo section. We'll jump back into the presentation and we are going to move on to the manufacture environment. So the manufacturing environment has seen some improvements, a lot of included toolpaths that are specifically for the manufacturing extension or previews that will go into the manufacturing extension. So I've highlighted that, in this case, inclined flat manufacturing extension option. So there's trying to avoid any confusion with what you're getting through standard fusion and what's being added or included now in the extension. So inclined flat is an option that has been brought into the flat toolpath. So the flat toolpath, very much similar to horizontal, just got a little bit better algorithm, finds those surfaces, or has better control over surfaces and machining over holes. Now on the tab for your 5th axis settings, you are able to include the ability to machine inclined flats. So this will find surfaces that are not parallel to your XY plane, or should I say surfaces that are not perpendicular to your Z axis. So it will use 3+2 positioning to position the workpiece and then do the flat machining. The connection moves between these will be 5-axis simultaneous. So your connection moves between components there are 5-axis, or between the flats are 5-axis simultaneous. With this, you can also set your maximum and minimum tilt angles. So how far away are you tilting from your either your setup Z or your tool orientation Z axis. And this limits the faces to be machined. You can see on the image on the right hand side there, with the max and minimum tilt angles that are set on that example, the angled face to the right hand side, where did that go to now? The angled face here to the right is not being machined because it is outside of those limits. So that is the inclined flats option. It's an included setting now within the flat toolpath. Moving on to A very big time saver is the deburr option. This is part of the machining extension once again, and this allows you to remove sharp edges or deburr sharp edges on a component. This edge selection, let me just jump past the 3, 4, and 5 axis, but edge selection, you can specify a edge angle, so the angle between the two faces that meet at that edge. You can specify that angle to limit the edges that will be deburred, or you can manually select. The specify edge angle is a nice way to automate this process so that you don't have to go and manually select all of the faces you want to deburr, or you can pick specific faces to deburr. Coming back up one, use 3, 4, or 5 axis allows you to limit your deburring operation to 3, 4, or 5th axis. So we can see there on the animation on the right hand side, we've got, just wait for it to loop back, 3 axis. So you're only machining in 3 axes, deburring. 4 axis, if you have rotary tool, you have rotary, you can do that on that. And then 5th axis, you've got your full 5 axis simultaneous deburring. And with this deburr, you essentially specify what we call the gouge depth. So you want to remove from that corner, let's say 0.2 millimeters of material to remove that burr that's potentially on that edge. That's the deburr operation. We'll move on to manufacture corner toolpath. This is an improvement over the pencil toolpath. So where pencil would machine corners within corners to remove excess material, and you can work down progressively smaller ball nose end mills, the pencil toolpath would typically machine along the corners. So if we had to look in the 2 pockets in this component, those vertical corners, the pencil toolpath would machine up and down parallel to the z-axis in those corners, where the corner toolpath is a better way to finish than the pencil. And the reason for this is that it machines across steep surfaces. So the toolpath is generated parallel to your XY work plane. And so it's a much safer and better way of machining those corners. And then from your shallow surfaces, it will machine along the shallow surfaces. Now we've got 2 words there, steep and shallow. Much like your steep and shallow toolpath that is available in the extension, the corner toolpath has a steep and shallow section. We'll see this in the demo, where you can adjust your threshold for what is considered steep and shallow, and you can set up your machining, your toolpaths specifically for steep areas and for shallow areas. This is functionality pulled from PowerMill, and the Fusion team is also looking at improving on this and pulling a bit more information from PowerMill and putting it into Fusion 360 with regards to that. Then moving on to the tool library, there's a couple of improvements within the tool library that is available for everyone to have a look at. When it comes to presets, you may have a tool that is set up with various presets, and if you are newly setting up a tool library, or you've gone through tooling changes and you want to modify your tool library, we now have the ability to copy and paste multiple presets. So you can grab, in this case here on the right hand side, I've grabbed 3 presets. We're able to copy those 3 presets and then select multiple tools of the same type. So let's say this is for a ball nose. We can then select multiple other ball noses, maybe the other diameters that we have, and paste those presets into those other tools. So you can copy as many presets as you want from one single tool, paste them into another tool, or paste them into a group of tools of the same type. Then there is also a public preview for 3D previewing of tools. So we get 3D previewing of tooling within the library, and there is also improved viewing of thread and grooving turning tools. So just a little bit of a mistake there on my part. The 3D preview is for all tools, and then there is a separate, I'll show you now in the tool library, a separate improvement for thread and grooving tools. So we'll go on to the demo. Let's have a look at those different options that we've discussed. So I've got one part here with a couple of those tool paths in there. Just some basic adaptive and drilling to clear out most of the material, but using from the 3D drop down the flat command, we're finding all of the flat surfaces on this model. And as I mentioned with the flat command, you'll see with a standard flat option you've got under passes your standard setup, but if you go to your tab for the multi-axis, we'll see that we can enable the option to machine inclined flats. With that, we will choose a tool axis reference, so measuring from either the setup Z or the tool orientation Z, you then set your minimum and maximum tilt angles. So right now I have a minimum of 0, maximum of 35, and we see that when this toolpath is generated, the face that is inclined here, that is 45 degrees, is not being machined, whereas the rest of the inclined faces around the component are being machined. I'm going to switch off the links here so we can see the toolpath a little bit better. And so you've got all your standard flat options. Within your passes tab, you can set your type, pocket, or parallel, but we now have on the sort of the axis or multi-axis tab, we can go to machine inclined flats and have that calculate out those inclined flats. And so we'll see here, do a quick simulation. I'm going to keep the part flat and then play this through. We will see that that tool has tilted to machine the side or the inclined side of the component. I'll play this through quite quick, a little bit too fast. Let's try and get that tool vertical. So if I have the tool vertical as if it was staying stationary and you had a bed machine with 5 axes, we can see how the part tilts to then machine those various faces. Okay, so that's your inclined flats option. We'll move on to the deburr and switch the inclined flat surface toolpath off there. And with the deburr, we'll see when you create the toolpath, you can select your tool. It could be a ball nose, it could be flat end mill. You can make a decision on what you want. Geometry in this case, we've got edges to deburr. I'm setting it to automatic to find all edges. And the minimum edge angle is selected here. That will essentially limit the edges that are selected. So we can see in the tooltip quite nicely shows us, it will look at the essentially the exterior angle between the two faces that are being interrogated, and we'll find from that edge, or should I say the edge being interrogated, it will find the exterior angle between the two adjacent faces. So I've got 15 degrees set here on this. We'll go across to the passes tab. We can choose to deburr either by chamfering or filleting the edges. I'm going to leave it on chamfering. And then you can set your edge shape, constant width or height. And then the actual width of the deburred edge that you are generating. So this is how much material you're going to be removing. So we'll see there, depending on your option, whether you chose chamfering or filleting, it will give you that width of that edge. Essentially, from the filleting side, it's the chord length of the fillet. And then what do you do if you cannot reach the corners? Do we deburr or do you cut with the tip of the tool? So you skip the deburring or cut with the tip of the tool to try and reach that. Under the 5-axis options, or under the tool axis options, you can choose to limit 3-axis, 4th-axis, or 5-axis for the deburring operation. You can also set to cut at a fixed point on the tool, and this is a point along the flute. So if you do not want to cut with the tip of the tool, we can set this value and it will adjust the tool path down. The flute will compensate down that percentage of the flute length. So we'll look at the flute length of the tool and compensate for that. See if we can get a tooltip up here quickly. So you can see there on the conical tool how it's moving that down to deburr with the side of the tool. So in this case here, we'll see in 3-axis, it's showing us all the corners that it can get to under that specified settings. And if we simulate this, I've got my accuracy down on the comparison, but we'll see if I just pause this, deburred this back edge, we can zoom in here and we can see, I'll probably have to boost the accuracy up, but you would see a tiny amount of material removed from there. Let's push the accuracy up here on the comparison. And this lighting's not playing part, but we can see that edge of material that's being removed. So there we can see, and this would indicate as a small gouge. So if I switched the model off, I think my tolerance is a little bit too big here, but that may indicate as a small gouge in your simulation when you're in comparison mode, because technically you are gouging the part when deburring, however it is by a small amount. Okay, I have a second deburr operation here. In this case, this deburr operation is set up with full 5-axis, and my primary mode for the 5-axis is to lead in, and the lead angle is 10 degrees. And so we can see here now, if we simulate this, it actually can reach a lot more of the edges. And let's get this tool orientation sort of vertical, and we'll play this and we can see how the component, full accuracy down here for the simulation. We can see how the component would then turn and tilt with those 5-axis moves. Okay, then lastly for this part, before going into the tool library, we've got that corner toolpath. And as mentioned, the corner toolpath is split up. You have steep and shallow passes, much like the steep and shallow finishing toolpath that we've got. I'll switch the model back on here. So part of that, we need to set our threshold angle that is between what is our threshold between steep and shallow. So here by default 30 degrees, and you can set your priority. Do we want to machine top surfaces first for the corners, or do we want to machine steep first? And once you've made your choices there, you can go and choose or set up your steep passes as well as your shallow passes. So we can see here the type, we've got a couple of different options. For steep passes across there will give you passes that are, I'll just cancel here, we'll see they are parallel to the XY work plane. There's those passes in the corners there being machined. And then for shallow passes, in this case it was set to machine along. And so I'll just go back into the corner. We can see the shallow passes, they are going along with maximum step over, or you can say along with constant step over. And then you can set your step over values and whether you want to up or down or both. So you've got those steep and shallow settings for the corner toolpath, as well as the tool axis modes. The primary mode, you have vertical. You can go through, set up your tool axis as per normal when changing over to using simultaneous machining. And that will then go through and I'll just simulate this. That will go, and we'll see that that uses that 5-axis. Clearly my tool is not set up correctly for doing the machining in the deeper pockets. Getting a lot of collisions there. Probably should have chose a better tool for this, but we can see it following and finishing up those lower and or the steep and shallow corners. Jump a little further along, we can see it doing corners there. Okay, one change I can make here is because I've got this primary mode as vertical, I'm going to set that to lead and lean and just set a let's say a 15-degree angle on both. Have that regenerate. We should see now we're going to avoid those collisions. While that generates, I'm just going to go into the tool library, and we'll see in the tool library if we select a tool holder, I've got the preview functionality, public preview functionality on for the 3D tool preview, so we can see that we're able to actually take that tool and tilt it around and view it in 3D. On the right hand side you do have a home button, takes you back to a 2D view, and this also works for turning tools. I'm going to grab a turning tool here. We can move that turning tool around in 3D space and view that tool. Now, when it comes to editing turning tools, I spoke earlier about OD grooving and OD threading. If we edit, or grooving and threading tools, should I say, if we edit that, we now get the central image for the tool that gives us a better idea of the dimensions being added in. So when we select overall length, we get an idea, or it shows us what the overall length of the tool is, and we get that preview on the right hand side as well. Now, just going back to the threading, should have gone here, OD threading, or edit the OD threading tool, and we can see two different views of that tool, so we can get the overall length, width, and we see on the side view the width of that, and then thread pitch. So just the improvements there on what you can see in the tool library. Now, just to jump back to the corner operation, we can see now we've got that turning and tilting in there. We can simulate. Going a bit fast. Okay, I definitely need to do some work on that toolpath. That is not going to be good for the machine, but you can go in and update and change your settings as needed to avoid those sorts of issues. But full 5-axis corner finishing toolpath available there. Okay, that brings us to the end for the demo. We're going to head back into the presentation, and we're going to close off with our summary. So overall, just to summarize what we've looked at improvements to your login security and the way that you log into the software. There's been a lot of improvements with performance. As I mentioned, something worth noting is the saving and opening of large assemblies. That's been a big pain point for some of my customers, and so it's good to see improvements there. And then there's updates to existing toolpaths, as we just saw, update to existing tools, as we saw the subdivide previews, multitasking with the automated modeling, being able to continue to do something else while the result calculates out. Use of milestones when inserting parts into assemblies, and then new functions with overall new functions, the automated center marks and lines, incline, flat, deburr, corner. So just a quick summary there, and as mentioned on the intro slide, Autodesk's Fusion 360 team does a very good job of putting product updates on their blog. So as mentioned in the description of the YouTube video, you will find a link below to that blog. I highly suggest you go through that, especially if you work in any of the environments that I haven't covered, simulation, electrical, generative design. There have been improvements across the board, as well as in additive as well. So, yep, thank you very much. That summary brings us to the end. I'm going to open up for Q&A. If there's anyone tuned in that has any questions, you can post them up in the chat and then I will answer those questions. Okay, so there's no questions come through. Once again, thank you for watching the video. My name is Carl van Rooyen. I'm an application engineer with Micrographics. If you did enjoy this video, please considering subscribing to our page, liking the video, and keep an eye out on our Micrographics YouTube channel. We are posting up webinars similar to this from various different application engineers, both in the manufacturing as well as the architectural environments. So encourage you to like and subscribe to our page as well as to our channel, as well as if you want, hit the notification icon to get notified of live webinars and video uploads on our channel. Once again, this presentation brought to you by Micrographics. We've got our contact details bottom left hand side there on the screen, so feel free to contact us if you wish to, or if you have any queries with regards to software or anything covered in this webinar. Thank you and goodbye.